Hi, if I may have your attention, thank you for coming today to the last day of SIGGRAPH and the one of the first technical talk sessions of the day. Hopefully you got a lot of coffee, and I think there's bagels outside, so if you haven't gotten one, please feel free to do so, or, stay and then try to get some after. It's your choice, you have freedom, or whatever. My name is Juan. I am the session chair for Realities of VR Production, and I have the pleasure of introducing our really esteemed speakers for the day. First up is the team from Google Earth to talk about the making of Google Earth VR. Here we have Dominic Kaiser, who is the engineering lead of Google Earth VR. He started the project while working on Google Earth. Previously, he was a technical director at Pixar working on procedural vegetation. Adam Glazier leads UX and sound design across AR, VR projects at Google. Prior to that, Adam helped bring Chromecast to the world and was also a designer at IDEO. I think I said that right. Yeah. Okay, cool. I'm terrible at pronunciations. And Per Carlson is an engineer on Google Earth VR, where he was working on rendering, navigation, sound, and haptics. Prior to Google, Per was a software engineer and technical director at Pixar. Let's please welcome all of them. Thank you.
Hey everyone, thanks for getting up so early for the last day. Thank you, Juan, for having us. I'm the engineering lead on Google Earth VR, and I've been working on Google Earth for about 5 years. And one of the reasons I like working on Google Earth is because the world is so full of interesting places. Like every year, my wife and I, we discuss where we should travel next with our limited vacation days. Should we go to India? Should we go to Moscow? Should we go to Antarctica? And there are just so many interesting places that we could travel to, but even if we had all the time in the world and there was no problem about money, we still couldn't explore every detail of our planet. And a lot of us felt that way at Google over the last 10 years, and so we started a project, the Google Earth project, where we captured every single angle of the planet with airplanes and satellites and cars. And we would have all these imagery and then use photogrammetry to fuse them together into one consistent model that results into one giant model that we can then bring to users. And once we had this model, we wanted to find ways to get this to users, to let users explore the world, to explore this beautiful model of our planet. And so we developed the Google Earth client, which many of you might know, that is on desktop and mobile and on phones, tablets. And it was great because everybody could discover imagery of our planet, but it also struck us that there's always this disconnect. Like we have this huge, nice, and beautiful model of the world, but we're just looking at it through a tiny window that is our phone or our tablet. And I come from working in movies, and I was always hoping that we could optimize for emotional appeal and just have people really step into the world and have it experience. And I was looking for ways to do so. And around that time, virtual reality had its renaissance. And it seemed like VR could indeed solve our problem. It could just remove this barrier between the user and the world. And so as we started experimenting, it turned out that engineering for VR is actually really hard, which many of you might know. One of the problems with it is the strict rules for immersion. So what we need to display in the headset exactly needs to match what the user and the human brain expects. If the headset moves, we have about 10 or 20 milliseconds to update the new image, and if we miss that, then the entire immersion falls apart. So that means we have 10 milliseconds about per frame to compute. And that is one thing if you have a very finite scene where you know exactly the number of geometric objects that you display. But in our case, we might have a normal city scene that takes maybe 1 million or 2 million of triangles, but we allow users to scale up or scale down and just go anywhere in the world. And once we zoom out to see the entire global model, we have a mesh that is trillions of triangles. And on top of trillions of triangles, we want to simulate effects like atmospheric shading, we have pre-computed atmospheric scattering, we have realistic sunlight, time of day simulation. And so to bring this all to VR, we had to completely redo a lot of our rendering architecture. We started with frustum culling, we did draw call batching because we're based on OpenGL. We eliminated a lot of the bottlenecks. And we actually gave an extensive talk about this last year at SIGGRAPH, when we weren't allowed to talk about this as a product. So we just said, here's a few experiments that we were doing about bringing Google Earth to virtual reality. There's a recording of that. Today, we don't talk a lot about the performance aspects of it. We really talk about how we take the experiments that we did last year and turn them into a product that people like. I want to start with where we started. So after a lot of optimization that would allow us to have our first experience at 90 FPS in VR, here is a recording of a person walking around in Monument Valley, really experiencing all this geometry for the first time as if it was in the room. And we showed it around and people loved it. Like we had the demo. A few days later, our founders, Larry and Sergey, came. They wanted to see the demo. We got creatives like J.J. Abrams come by Google and look at it. And everybody was amazed, but they really wanted more. They didn't want the world to end whenever they hit the wall. They wanted to just keep walking and keep exploring the city. But we were limited to this 3 by 3 meter room that all the contemporary VR systems give us. And so we had to completely think outside of the box. Like, what do we do to allow people to navigate large open spaces? And that is not so much of a technical problem in the first instance. It is more of an interaction design problem. And so I'd like to introduce Adam Glazer, who is our interaction designer on the product, to talk more about navigating in Google Earth.
Thanks, Dominic. So about 2 years ago is when we started thinking about the UX. And at that time, to set some context, all we had was a prototype Vive, and the DK1 or DK2 was around. There was a few third-party apps, and most of them were interesting demos, but none of them provided great ways to get around an entire planet. And so we really, at this point, didn't know what we were doing. We didn't know what the best way was to allow users to get around an entire planet. So we did the simplest thing possible to start, which is wherever someone points and clicks, we teleport them to that location. And this worked to a certain degree because people could quickly get to the top of a mountain or down a street. But one of the major problems was when someone teleports, they lose context for they were standing way back there and now they're standing on top of a mountain, and they get to the top of the mountain and look around and sort of wonder where the mountain was. Even though logically they knew what they did, there was always this disconnect, this loss of context. So teleporting was fine, but people often wanted to explore things at different scales. They wanted to get up at human scale or get to Godzilla scale and survey a whole city. So we allowed them to click up and down on the touchpad to change their scale. And while it's cool that you can change your scale, it wasn't cool that when you shrink down, the thing that you were just looking at right below you all of a sudden starts to move further away because you're shrinking. So this created a problem. With teleport and scale, you'd have to end up teleporting, scaling. It was a lot of work and you lost context doing it. So to aid in the context loss with teleport, we thought, oh, well, what if we, teleport the user halfway to their destination so they get like some context. This worked okay. They still lost some context, or maybe lost a little immersion. But often when they'd stop halfway, they'd be looking down, floating in the air, and some people would be quite frightened by that. So at every step, we then scaled the user so that their head was in the same position, but their feet were now on the ground. And this worked actually pretty well. Like we thought that changing the user scale might feel too weird because you're basically changing their the width of their eyes. But it worked well. But we still wanted more. There was still this loss of immersion having this stepped motion. So what we did is continuous movement using the same technique, and we call this flying, scaled flying. And this worked extremely well to preserve context, to preserve immersion, and let the user just roam around wherever they point.
The one big disadvantage, if you're familiar with VR, is that if what you see and what your body feels are different, you end up getting really sick. So this made basically 95% of the users completely sick. So we had this problem. It's like flying was awesome in all these ways, but it caused nausea. Teleport was efficient, but you lost context doing it. And we really wanted to try and find a way to end up somewhere in the middle, where it ends up being easy to use, we preserve immersion, we preserve context, and no one gets sick. So we came up with this really cool trick, which is while you're flying or while something's in motion in VR, you can see in the outer edges of the user's periphery, we project a grid that represents the floor of the room that they're standing in. And we also have a horizon line. And as you can see, it really only ends up needing to be about that outer 15%. And that's enough to give the user the same feeling they have when they're in their living room, which is the living room's not moving, but the stuff on the TV is moving. And that's why people don't get sick watching things in living rooms. So the key finding here, we did a lot of research to figure out what the right size was, how much blur, and all these key elements. And the main takeaways are you only need about 10 to 15% of an aperture inset from the total field of view. You need a horizon line, and you need high contrast elements on the floor. And for the floor, we tried different patterns, like cellular patterns, things that look nicer. But the grid ended up being making more people feel comfortable. So with tunnel vision and flying, we ended up pretty close to the middle. We lose a little bit of immersion because you get this artificial room coming in, but we believe that it's pretty close to the middle because it's such a small amount. And actually, a lot of users don't even notice it. Once you fly up to really, really high altitudes, you end up being so big that the Earth is essentially like a few meter radius marble underneath you. And this becomes problematic because it's uncomfortable to look down. And it's also foreign when you're standing on this marble, you're not sure where north is. And people just ended up getting lost and feeling uncomfortable. So we give the user the option to put the Earth in front of them at any time so that they can navigate it in a familiar way, like they do on mobile or desktop. And to make up for the fear of heights, we project a subtle floor that follows them around so that they don't just feel like they're floating in space. In this view, users naturally, instantly wanted to drag the Earth like they do on mobile, to rotate it and find places they wanted to go to. So we allowed that. And the way that we do that is we project a proxy sphere around the Earth's surface, and wherever the user's cursor grabs, it drags that proxy sphere around. So when you apply that same technique in terrain view, when the user's standing on the Earth, it works pretty well when you're on flat ground, because that proxy sphere is the size of the Earth, which is pretty close to flat ground. But the problem is when the point that they're dragging is above them, that proxy sphere is now above them, so they end up dragging themselves into mountains, into buildings, and they don't like that. So to solve this, we came up with a really cool solution, and we call it cone drag. And what cone drag does is we project a proxy cone around the user's foot, and the top of the cone is the point they're grabbing, so that when they drag down, they never end up intersecting the point that they're grabbing. You can end up with a few cases where the user ends up getting somewhere they don't want, but in most cases it's fine. And if the user lets go halfway, we just scale them up over the course of a few seconds, and this ends up being really fine. So here's an example of cone drag. You can do things like feel like Spider-Man jumping from the tops of buildings. So I just mentioned a lot of stuff, a lot of the things that didn't work and did. And just to summarize, Scaling the user while flying worked the best for us, but only when using tunnel vision. And cone drag solved these problems when, to prevent the user from dragging themselves into things, and making sure there's the option to put the globe in front of the user, help them get around. So getting all these basics took a lot of time, and they're important, but making it feel right and making it feel delightful took a whole nother level of work. And for that, I'm going to introduce Per, one of our engineers.
Thank you, Adam. My name is Per Karlsson. I'm an engineer on the team. Once we had figured out how to do performant rendering and we had the navigation needed to go anywhere in the world, we thought that we were pretty close to the final product. And we were a little bit surprised when we showed it to people, and we didn't really get that much of an emotional response. We would hear things such as, it's cool, but it feels kind of artificial. So we were thinking, how do you make this feel really good? How do you make it feel natural? And ideally, we want everything to be as realistic as possible, which can be hard to do. But how do we do our best to close this bridge between what's in reality and what's possible to do in VR? And how do we communicate with the user that they're actually interacting with this really huge planet called Earth? One of those areas was dragging, as Adam just mentioned. Dragging was, initially, we started off treating it very similar to how regular Google Earth does dragging, where the intersection point is sort of working as a direct manipulation. It moves one-to-one wherever you're pointing. And this felt really good on large scales when the planet is really small in front of you. But for smaller scales, when you're much closer to the ground level, it didn't really feel that good. It felt like it's responsible a little bit too well. It feels like the planet doesn't have any weight at all, which is exactly the opposite of what we wanted to achieve. So we realized we need to do something here. One observation that we did early on was when you were pointing very far in the distance and just starting the dragging gesture, just by holding the hand still, it could sometimes do this jittery motion because it's very hard to press these buttons without moving the controller just a little bit. And based on this, we figured maybe we can do some kind of smoothing based on how far it is to the thing you're pointing at. So you do more aggressive smoothing if it's really far away, and not so much when you're pointing at something closer. And this was enough to get rid of that little jittery effect that we were seeing before. But it still didn't solve the main problem. It still didn't feel like we were interacting with a heavy object. And we thought, in real life, if you have a really heavy object in front of you and you push it, it's not going to move until you give it just enough force and it'll start moving. And this is because of friction. So the next thing we tried to model the intersection point. We simulate a point that's always targeting wherever you're pointing. And then we can apply a spring equation. And then we choose the parameters in such a way that the damping ratio is more than 1, so we don't get any overshoots. And then it becomes trivial to implement friction because it gets kind of easy to switch between static and kinetic friction. So now, when you started the dragging gesture, just by pressing the button we had assigned to the dragging, and with very little hand movement, nothing would move. So that was really cool because it really felt like something was fighting back. Something is preventing us from moving this planet. And because of the spring, the properties of the spring, it would create this little lag effect. Like it would kind of create this little delay, which was really cool. The problem that we were seeing, it was really hard to find the right spring parameters. Because as we mentioned before, we are constantly changing the scale. And how do we find a spring stiffness that works in all the scenarios when we have different scales and we're pointing at different distances? So we realized we probably need something that's a little more robust that works in every situation. So we realized instead of looking at where we're intersecting, how about if we look at the controller instead? We had this idea that it's probably all the high frequencies in the controller that's causing this very responsive feeling. And we figured maybe there's a way to, like this ray that we use for the drag gesture, maybe we can filter it somehow. And we ended up, this looks really fancy, by the way. It's not like we did Fourier transform and cool stuff in frequency space, but we basically defined something that we call low-pass filters. So we had one very strong filter and one weaker filter. And then when we started dragging gesture, we remember the transform of the controller at that point, which means both position and rotation. And then as the dragging gesture continues, we choose to blend between this filter based on the distance or the angle between these transforms, which means when you start the dragging gesture, we apply all of the really strong filter, and then the further away you get from the initial transform, it gets weaker. And this created an effect that was very similar to the spring experiment we did, where it had some sort of like static friction feeling to it initially, and later on it would create some lag. But then, now, we have this problem of we're actually not intersecting with this laser that's attached to the controller. This filter laser we have is actually not even guaranteed to be following it from the root of controller. So we needed to come up with a strategy to render this so it looks nice. So we have the post-filter array and the pre-filter array. And what we ended up doing was we took the intersection of the post-filter, and then we project it through pre-filter. This creates a really nice hole, and we can use this hole to put control points of a Bezier curve. And now we get a really smooth curve that we can display. And it might look a little bit awkward if we display the whole curve. It looks like some awkward thin spaghetti attached to the world. So we did that a little bit, just fading out the opacity the closer you would get to the intersection point. We also wanted to play around more with haptics. Like, if you in the real world, if you maybe, let's say you attach a rope to a really heavy object, and then you pull this rope, it feels like the rope, like it feels like it's fighting back a little bit. There's some kind of resistance. So what we did, we compared intersection points of the filtered ray between 2 consecutive frames, and then we compute the angle between these points and the head. And then we get a really nice scalar delta angle, and we can use this delta angle to drive the strength of the haptics effect. So the more aggressive you remove the controller, the more of the haptics we could apply. What was nice about this nice single scalar delta angle was that we can use this for sound effects as well. We ended up developing 2 dragging sounds, one fast and one slow. And then it was really easy to blend between these 2 sound effects based on this delta angle. And it worked out really well. So here's an example of just showing this new dragging. And the red thing you're seeing here is just for debugging purposes, showing the laser before it's filtered. And without that, it looks like this. So here I'm doing some very exaggerated motion, but it's not as responsive as before, and you see a little bit effect of the bendable laser. Another problem we had to tackle was flight speed. We decided that this scale flying that Adam mentioned before, it was probably one of the most navigation method that users really wanted to use, and we didn't really know what kind of flight speed are we going to use. As many of you might have heard, acceleration in VR can be one of the things that's causing motion sickness. And based on this, we thought we should probably keep the flight speed constant in room space. And this was our first experiment, and it worked kind of well at larger scales, because now it's really quick. Like say you fly up, your scale gets huge. To go from city to city or country to country, it was possible. But it didn't feel good at all once you got to lower scales. Even though you had the same speed in room space, it felt like you were entering some layer of glue. It was very annoying, very frustrating to use. And we realized we probably need something different. So we end up modeling flight speed as a power function, where we can have much higher flight speeds when the scale is low, and then have it nicely decay. And what we do actually, after a certain amount of scale, we switch back to a constant flight speed, just to still achieve the effect I was talking about before, when it's possible to fly really fast from, let's say, a city to a city. And here's an example of showing how this nicely changed based on the scale. And lastly, I want to talk a little bit about some of the sounds we designed for the application. When we give the, I was talking before, when we give the demo, when we had the rendering and the navigation done, a lot of users complained that it was very, very silent, very empty, very dead inside the app. So we had to work with a sound designer to come up with these sound that would really sell the idea that you're actually in these spaces that you're looking at. And ideally, you would want some kind of sound that is really tied to the location you're at. But this turns out to be a really hard problem because there's a lot of different places to cover on the planet. So we ended up designing these location-neutral sounds for these 4 different regions you're seeing here. And what we do, based on wherever the altitude of the user is during the application, we convert this altitude into some logarithmic space. And once in the logarithmic space, we can blend between the sound sources. And the effect is it feels really good, just like flying up and down, and it really feels like you entering these different levels. And as Dominic mentioned before, we also have this ability to change the time of the day in the app. And this meant that we had to support both a day version of all the sounds and a night version of all the sounds. And for the day and the night sounds, we just have to interpolate between them based on the time of the day. And it worked out pretty well, and users had a lot of fun when they can change the time of the day and they could hear like the environment got different. So that was very successful. If some of you haven't tried the Earth VR yet, we have made a little video just to demonstrate all these concepts that we talked about, all put together. Okay, I think that's all we have to say. Do we do questions now, or? Okay. Thank you. All right, questions?
Beautiful, excellent presentation. This is one of the VR's gems, and thank you for opening it up to us. Can you talk a little bit about like the tunnel vision when you're flying? I heard about that when you guys came up with that. Is that something you guys came up with? Has that been used elsewhere? Because that literally made history when you guys did that.
Can you hear me? You want to hear about the process or other examples?
Yeah, the thought process, especially like, were you inspired by other work, or did you just through testing?
Tunnel vision, the backstory behind how we explored it turns out some other people limited field of view in the past, but no one was projecting a floor and doing some of these other tricks. But we didn't know about that. What we did was when we were dragging, dragging was making people sick. So we ended up like basically masking the world into this little circle. And so that when they dragged, they were just dragging like a little patch of the earth. And we're like, oh, that works really well. Like no one's getting sick from dragging. And then we were sitting in our, at our desks, and we're like, what if we just turn that circle in screen space so that when you're flying or dragging, you still have this empty area. So it was just this evolution of sort of realizing like the things that we need, which is like we need only something moving in the screen. We need some static elements. And then the high contrast lines were another discovery, and then the horizon line was like even another one. So we just sort of slowly kind of built this up and from that.
Beautiful. I mean, that's now become the way, the de facto standard. So please.
I also want to mention we had some really brave people that were really sensitive to motion sickness and agreed to over and over come to our desks and try us
And
to
even
tell us
braver-
whether we do a better job.
Even braver people to clean up the vomit. But beautiful, thank you guys. And if some of you guys haven't seen it, it's in the video. It's literally one of the most innovative mechanics for locomotion in VR, and thank you for giving that to us.
Thank you.
Thank you.
Hello. I just want to start off by saying that this is by far my favorite VR app. I've spent more time in it than any other app, all the other apps put together, so thanks for that. My question is, do you guys have any plans for adding maybe an API to this so that we could put data overlays in it or stuff like that?
Yeah, we've definitely, I mean, it would definitely be nice to do something like this, but like even just getting this out of the door as a polished end-to-end experience where we have 100% control over frame rate and amount of content was pretty hard and took us a long time. So it would be nice to explore that in the future, but there's only so much we can do at once, and we'll see what happens.
Yeah, it makes sense.
But thanks for asking.
All right, thank you.
Hi, beautiful work. Couple of quick questions. Does it map the entire globe in 3D at this point? So I can go anywhere in the world and we'll have full 3D data at this point?
Yeah, so every latitude, every longitude has a defined color and a defined height. And if we have high quality data from some close-up source, then that pixel color mainly comes from, you know, as like high resolution. And otherwise we always fall back to satellite imagery. So you can go anywhere. It just depends what quality you might get.
Right, and in terms of this 3D imagery where you have cities in 3D, are you removing the shadows from the, because it seems you have dynamic time of day as well, right? So the baked shadows in the textures, did you programmatically remove them, or do you have multiple sources of imagery that lets you generate the textures after the fact without the shadows?
It depends on the imagery source. Like we do some of that in imagery sources where we have every texel sampled from like 20 different directions. Then you can do median filtering and all this kind of stuff, but we don't always have that. Plus, yeah. Yeah.
Okay, thanks.
Thanks. I have to agree, it was an amazing app, and just a few days after it came out, we ran the first experiment with it. As one thing we noticed, so depending on how fast your internet connection is, I mean, it's a challenge, obviously. What do you do to try and, or I assume you do something to try and predict where people will go and preload all of these kind of things for those poor people who don't have glass fiber at home?
Yeah, once we did download all the highest resolution imagery where you are, we kind of try to gradually expand the radius and predict where you're flying. But there's only so much you can do without a, you know, without a brain reading interface. So we're trying to kind of do a breadth first search around where you are. But ultimately, we do recommend a fast internet connection. There's not really a way around it.
Hi. You were mentioning that at first you had most people experiencing motion sickness. Now with all these changes, do you have a number on what proportion of the population might still experience motion sickness, or have you solved this completely with this?
From my experience, we ran lots of user studies and had lots of friends and family try it. I'd probably say around 2% like still say that they're sensitive. But what I've also found is those 2% are sensitive to almost anything in VR, like even just putting on the headset. And that's like the persistence or just this brain change that's probably causing it. So, but we're still interested in trying to address that, like with future hardware and stuff. But yeah, in certain circumstances, tunnel vision's not enough. Like it would be better if the aperture size was smaller. And one of the ways we got to that aperture size was like, we actually found something that was even more aggressive, like where you barely saw it, but people with glasses, it pushed the headset forward a little, so they weren't seeing it. So we tried to find a happy medium with that.
All right, thanks.
I guess my question kind of piggybacks onto that. When the grid on the floor is displayed, it takes up a significant portion of the view. Is what you've done there, is that the best optimal setting, or can you get away with showing more of the scene and less of the grid?
Yeah, so when we started, it was just black, and then we were like, oh, well, we should show a grid, so it was like black plus a grid. Then we tried average colors, and that wasn't great. So then we blurred the scene in where the grid was projected, and that was about as good as we could do to kind of like make it so it wasn't as noticeable. But essentially, if the grid is, your periphery cues in on high contrast details. And if it's too busy, like it's a natural pattern, like cellular pattern, or if the lines aren't contrasty enough, then your periphery has nothing to grab onto, and then it's meaningless, like it doesn't see it. So it's this weird balance of like, we have to make sure your periphery and your sort of almost subconscious sees it, but riding that line between it not being too obvious to your consciousness is like, it was really hard to figure out. But I feel like where we landed was as aggressive as possible, meaning as aggressive as like as little as possible for the Vive and Oculus. Now when like field of views get wider and frame rates get faster and like the screen resolution grows, like we might be able to get away with some different things.
All right, thank you everyone for showing up so early.
Thank you for that. So if we have time later, we will try to see if we can have more general Q&A sessions with our presenters. But while the next session sets up, please let me introduce Penrose Studio and their talk, Building an Animation Pipeline for VR Stories. Terry Callejas is an FX developer at Penrose Studios and one of the main architects behind Penrose's unique VR animation pipeline. He previously worked as an FX artist at DreamWorks Animation. Bruna Berford, did I say it right? Okay, cool. Bruna Berford is the head of animation at Penrose Studios. Previously, she worked as an animator at Oculus Story Studios and a cinematic artist at Telltale Games. Do you guys need a few more minutes? Or? Okay, let's please give them a very warm welcome. They did a really awesome demo at Real Time Live. You should have been there, you should have seen it, but if you haven't, this is an opportunity to learn more about it. Thank you.
Hi everyone. Hi everyone. Thank you for everybody for coming. My name is Bruna Berford. I'm the head of animation at Penrose Studios, and over here I have Terry Callejas, FX developer and one of the key developers of Penrose Maestro tool. So today's talk is going to be about how we have modified VR, a traditional film pipeline, to fit this new media of virtual reality. So first, who are we? We are Penrose Studios, a San Francisco-based startup founded in 2015 by Eugene Chung, and we create content for augmented and virtual reality. So these are the 3 experiences that we have produced so far. The Rose and I, that was premiered at Sundance in 2016. Then Animate, which was the first VR red carpet and held in Tribeca in 2016 as well. And our latest piece, that is Arden's Wake, that we premiered the prologue at Tribeca in 2017. We are a diverse group of people from DreamWorks, Pixar, Oculus, and game studios, whose mission is to define the next generation of human storytelling. But in order to define this new language and make the most compelling stories for VR and AR, we realized that we have to create the content and also the tools to develop them, so we could unlock the full potential of VR creation. We needed to become more native VR thinkers, which means spend more time in VR and thinking outside the borders of a flat screen. And that translates to the movies that we create. With each film increasing the level of complexity, we have been constantly challenged to create and develop like a better pipeline and tools that would allow us to push the limits of what we wanted to create. And even though like each movie has a different style with their own technical challenges, we noticed a couple of similar problems on the process of creating them. So I'm going to start by pointing out some of the animation challenges that we faced during the production, and then we're going to talk about like some of the solutions that we found to fix them, so like layout tools and network review. So most of the animation problems that we found were related to the fact that we were coming from a framed media to another one that had no boundaries, right? And that usually means that more freedom also comes with more work. So the first thing that we had to find was a way to teach positional tracking to the viewer. In other words, is to teach the viewer that they had the ability to look around, move around, and explore this new world that we were creating. And bonus point if you can do that without having to tell them anything. So on this new movie, I'm sorry, a little bit spoilers here. On this new movie, Arden's Wake, we made sure to fully utilize the environment around the viewer to tell the story, kind of forcing the viewer to look up, look down, look around, and actually like move in the space. So we used a lot of theater and dance cues to guide the viewer's attention and lead their eyes to where is important, like sound cues or reducing the background character's movement compared to the main action. But it was still a challenge to think about crafting this scene without utilizing the full environment around you by looking just at a flat screen bounded by the 4 corners. And more like letting the viewer move around means more animation to do. So here's a scene from Animate, our second movie. And we quickly realized that there are no shortcuts. You do have to animate everything as if all the shots are wide angle and full body animation. So a shot like this, where following the woman is the main action, and this is mainly where the viewer would stand in the experience, we thought it was going to be a fairly simple shot. But we have to account for the viewer moving around. And we do have to animate all the characters throughout the entire scene, even though it might not be the center of attention at that specific time. So yes, someone has to animate the other character going from point A to point B and leaving the stage. And someone also has to animate the other character inside the boat, waiting for her rescue. So here we opened the side of the boat so you could see it, but in the experience, the side of the boat is closed, and the viewer has to actually like poke their heads inside the boat to find the action. So there was no way around it. All the shots were full of hidden animation to do. So moving on with the no cheating idea, comes another challenge that was to change the way that we were posing our characters. So I like to think about this image as being a traditional CG movie. So here the silhouette is working, the pose is perfect for the camera, and that's all that matters, right? So this is traditional CG, and this is VR. So here every angle matters, the way that she's putting her hand over her knees matters, the way that her feet are on the ground matters, every single detail on that pose matters. So we realized that VR is more about sculpting and less about the silhouette. And if the viewer could see our experience from every angle, that pose should also work from every angle too. So this leads to another challenge that was to create a good staging with multiple characters, with different scales, and things that were swimming around you all the time, like on these boards from Arden's Wake, our third movie. So staging well your shot is super important to create an emotional connection with the story. Depending on where you place the viewer and the characters, a scene can become more intimidating or scary or funny or just less powerful. So on Arden's Wake, for example, we had this very difficult scene where we had a huge character swimming around a tiny little submarine. So how do I even start blocking out the shot, right? So with such different scales and no environment to ground me, it was really hard to figure out like the position of the characters and where is above my head, where is eye level, and how far things should be. And looking at a flat screen, you don't even realize how huge this rig really is, this dragon really is. So figuring out this path and where to place the elements and how fast things should move without a tool that would actually allow me to do that straight in VR was extremely time consuming. Because every time that I wanted to see a tiny little change, I had to export more than 2,000 frames of 3 characters all the time. So just as a curiosity, this rig of the dragon on a default position, it's bigger than the length of the entire plane that we have on the ocean plane that we have on the experience. And the viewer is like next to the cone of light, the yellow little cone of light. Okay, so how did we solve some of these problems, right? So in order to solve some of the animation problems that we had, our amazing team of engineers here created a couple of tools for the animation team. So the first one is called a layout tool called Dollhouse. And we basically extended the VR editor component of the game engine to attend the needs of the project. And it addresses the issue of crafting a well-staged scene that fully utilizes the environment around you straight in VR. So instead of trying to figure out the correct position based on a flat screen. So with this tool, I can grab the object, I can position in VR and keyframe the object relative to myself in VR. So once I'm happy with the animation that I did, I can export that animation to a third-party software where I can keep refining that animation. So this way, I know for a fact that the position of the objects are correct relative to me in VR. So this was our pipeline before Dollhouse. We used to animate on a flat screen, review on a flat screen, export to VR, and then review in VR and realize that we need to do some fixes and then go back to that loop. But it's not very like a good loop when you have to do that like iterations like so many times, right? So because it used to take me like a long time to do like just one small fix. So now we cut this loop by half, making it extremely more like straightforward. So now we animate in VR and we review in VR right away just with like play and pause. And the good thing is that we can do that with all the pipeline, like in model, animation, effects, layout, set dressing. This was extremely helpful to increase the productivity of our pipeline. So next I'm gonna hand it over to Terry, who's gonna talk about the next solution that we find.
Hi, everybody. My name is Terry Calais, and I'm an effects developer at Penrose Studios. And I'm going to be talking about our network review tool that we call Maestro. So what exactly is Maestro? Maestro is our infrastructure for organizing our stories. It's highly dynamic, and it's adaptable to accommodate a changing production environment. It's also our network review tool, So we actually do all our reviews in VR now. Maestro is built into the game engine and into all of our projects. Maestro is also integrated into the rest of our pipeline, so we can export drawings and other useful information and pull it into third-party programs. And I have some examples to follow up with this later on. So, as I mentioned before, Maestro handles the infrastructure for each of our stories. Transitioning between scenes becomes as easy as selecting and pressing a button on a remote. Our system also allows us to exercise a lot of precision into where in the story we want to jump to. So we can skip ahead 5 seconds, pull back 5 seconds. We can also go to the exact individual frame that we're trying to review. Members of our animation team also requested a loop in, loop out feature that we put in, so we could focus in on one small section of the animation and play it over and over. This is something that's really important that they have in other cinematic tools like Maya, but we wanted it to be able to review in VR. By defining our story sequence via a simple script, we can focus on the actual production versus having to hard code a story infrastructure in the game engine every time to be able to jump between sequences. We also can accommodate really long VR movies where it wouldn't necessarily be possible to load in all the assets into memory at once. So here's an example of how one of our stories might be organized. Because of long sequences without cuts, we've needed to split up shots into smaller chunks and create pose matching scripts for the animators in order to make sure that the sequences flow together seamlessly. In addition, our stories are split up into different environments, which have entirely different groups of assets. So that's represented here by these scenes in green. But how do we move between these scenes without loading screens or long waits during transitions, which you don't necessarily want to do during a VR production like you would if you're cutting to a cinematic sequence in a game? This can especially be problematic when you're releasing something on a console where you don't have the same memory bandwidth that you do on a PC. Well, we actually have a pretty simple solution for this. Maestro manages the sequences by making sure that the next sequential scene is always loaded into memory as soon as the current one begins playing. This ensures that we never hit any loading hitches, and we don't need any loading screens when transitioning to a memory-intensive scene. As long as the production can handle 2 scenes loaded at once, we can play through the entire story or movie without a hitch. For the actual implementation, we're actually using Unreal Engine for our stories, and asynchronous level loading techniques built into the engine are really useful for us. So before I get into the networking side of things, I just wanted to show you guys how our old review process used to be. So here you can see the director in the headset. We have a group of animators that are kind of standing behind him and looking at this 2D screen to try to see what he's looking at. There's a lot of confusion that comes up because you can't really tell what the director is looking at or pointing at. You also lose things like audio spatialization and stereoscopic visual effects. So something on the screen is going to look a lot different than it does in the headset. But what if everyone could be in a headset and exist in the same space looking at the same thing? And that's the problem that Maestro is trying to solve. So here's an example of a model review inside of Maestro. Everyone wears a headset and has an avatar with head and hands, and we have some basic locomotion so you can move around the world. We use the built-in microphones on the headsets for voice chat. It's enabled automatically so everyone can hear each other. Back at Penrose, we have an open office, so we want to be able to have reviews without shouting across the room, which can end up being a big distraction. This was actually the case before we implemented voice chat. It was really hard to get any work done with people shouting at each other. So they're gamified and simple representations of people, but they're really compelling in making it feel like that person is right there next to you. Playback is synchronized across all the clients, and everything is handled simultaneously. Starting a review ends up being a one-click process, which is executed from the main project. There's no separate process or separate program that we have to open up to jump in. Everything is directly in Unreal Engine. It enables us to work off-site and have intimate reviews. During our film premiere at Tribeca, we were actually still able to conduct animation reviews, even though half of the team was in New York and the other half was in San Francisco. So even though we were across the country from each other, it still felt like we were in the same room. So in addition to voice chat, we give a few other key controls to the artists. So 3D drawing strokes with colors and laser pointers are given as soon as you launch into Maestro. So more recently, we've actually added in simultaneous department reviews using review rooms. So we can have an animation review at the same time as an effects review, and people won't be bothering each other. After the review, we can export the drawings back into third-party tools for reference. And each of the drawings actually contains metadata that synchronizes with the frame number in the third-party tool that you're using with the frame number of the story, so that there's no question about what the drawing is referring to. You just scrub to that exact frame, and you can see what the drawing was pointing at. We actually use Maestro for all reviews now because it's a much more effective way of communicating with each other. So we implement all the playback controls on the client side because it's easier for us in the engine, but then who has control of the playback when you're in a review with a bunch of people? Should anyone be able to take control at any time? What if two people issue a conflicting playback command at the same time? Which one can take precedent in this case? So our solution was to use a Lamport logical clock to deal with collisions between important control events. So this is a pretty standard, simple algorithm that's used in distributed systems. It's pretty simple. The way it works is the client and the server both have clocks. And when a client sends a message, it actually encodes with the message a time code. Now, this clock isn't like a real clock, like a timestamp. It's actually just an incrementable clock that is only incremented on the server when we process a message. So when the clients receive a message, they just synchronize to the server's clock, and that ensures that they're synchronized across all the clients. So now I'm going to take you guys through a basic example using Maestro that I've used in my own work. So I'm a developer, but I also do some effect shot work every now and then. So here I have the storyboard from the opening sequence of Arden's Wake. There's a boat that's kind of falling down. There's a bunch of debris. There's a couple of characters. But there's a lot of questions when I tried to pull this into VR, like where the viewer should be, what the scale of the object should be, where the debris should be located around the viewer. But luckily, I can use Maestro to communicate with my team to figure out the answers to a lot of these questions. So here I am in a review session with my coworker, Devin, after a first pass trying to get the objects in their correct positions. Really easy for us to just hop in. I can just navigate us both to the exact sequence I was trying to review. Here he is, and he can easily take a look at the positioning of this broken propeller that I wanted some notes on, and give his visual drawover of what he thinks I should position it. So after letting him know that, this is where I think the propeller should go, I'm really great at drawing, so it'll be an exact replica of what the propeller is. I can then go ahead and export it and pull it into any third-party software to see what I need to change for the animation or simulation. So in this case, I'm using Houdini, but these are just FBX files, so we can pull them into any software, and it lines up. So we have a lot of features planned for Maestro and Dollhouse in the future. For Dollhouse, we would like to extend functionality beyond Leia and be able to pose and animate rig characters in VR. It's just another step closer for us to close the gap of using third-party tools that are built for native VR. For Maestro, we want to have animated drawings. So this would be the ability to, as you draw, encode the frame or encode the actual animation of the drawing. So you get timing information. And this would allow us to pull it into something like Maya and be able to animate with the actual animation. It's something that's really helpful for the animators. We also want layers. So this would be the ability to draw on different layers and then toggle the visibility of each layer in order. So this would allow us to do storyboarding in the engine, all in VR. We also want to add brush shapes and styles. So this would give any of the artists the ability to express themselves a little better in VR. And what I want to stress is this is an actual production tool that we use every day. So we use Maestro every day, and because of that, it gets better every day. So it's definitely something that is really helpful in all departments at Penrose that allow us to make content the best we can, I guess, in VR. So here are some really great resources that were used in Maestro and the various parts of this talk. You guys can talk to me afterwards if you're interested in getting a copy of these. And I just want to say thank you to the Penrose team and artists for coming up with amazing stories to push the boundaries of VR technology and pipeline. And specifically, I want to thank the engineering team, a lot of who are right here, up here in this corner, who maintain this software and improve it every day so it's an active part of our pipeline. And we're definitely hiring. So if you're interested, you can just come up and talk to us after the talk. Thank you. we have any questions, I guess?
Question. Are you going to release Maestro as a standalone product at some point?
So we built in Maestro internally as a tool to be able to create the best content. So we're working on it internally, basically, but we don't currently have any, I guess, plans, but we're definitely thinking about the options of being able to release it. And a lot of the things that are built into Maestro are not necessarily engine specific. So these are just a lot of techniques, I guess, that we've been kind of implementing and we wanted to share with you guys in case you wanted to, where you're creating your own VR content and be able to kind of pull it into maybe other engines. So a lot of these things are not like the most technical challenging, I guess, to implement, but they're definitely something that has been really useful and for us to be able to create the best content that we can.
Hey, first off, I'd like to say it's very nice. I really love the style and everything. And where can we see like your shorts? Is that on Oculus Store or something?
Oh.
Yeah, we have Arden's Wake playing on the VR theater here.
Okay.
If you
good.
can get a ticket to it.
So my actual question is visual fatigue a problem? Like, because you're animating in 3D and you're reviewing in 3D, so is it ever a problem, like visual fatigue at the end of the day? Because
I honestly, like, I'm getting used to it. Like, we already spent like 2 hours on an animation review and everybody was just fine. Like,
okay.
we are getting every time, because we use it at VR like every day, so I think you get used to it.
Okay. Okay, good. Thank you.
Hi. Looks really good. I just had a really quick question about scale related to Maestro, handling either multiple people in the session or multiple sessions, or if you have any recommendations or thoughts about that.
Yeah, so we've actually been able to have up to like 15 or 20 people. We definitely had a couple of tests where we pulled the whole studio in. So our network engineer was able to make a really lightweight system where we're not updating on every frame. So basically the world state, which includes playback information about where we are in the story, as well as all the positions of everyone, gets updated as needed. So if people aren't moving that much, they're not getting updated. And it's a really small amount of information that needs to travel across the network. So we haven't tried it with hundreds of users at this point, which would be really awesome. But yeah, we've definitely been able to get 15 to 20 people in at the same time.
Thank you.
Hi, I wanted to ask you about the runtime notes, the CineSync style notes that you were doing in the VR environment with the sketching. Did those go through to the, I saw that was going into Houdini. Do they also go into Maya, and do the artists get those notes in spatial form?
Yeah, so the drawings are just exported as FBX files. So you can pull them into any program. Any program that can kind of use them. Maya has like FBX export. The one thing about Houdini was, I did have to do really basic transform to get the YZ up, but other than that, it was just one node. All right, thank you.
Thank you for that really great talk. We have one more speaker, but I haven't met him yet, unfortunately. If he is here, I would love to see you. Oh, there he is, I think. Pretty good. It's very awesome to meet you. Okay, please come up. Sorry, like, impromptu awkwardness is always really awkward. Yeah, I used awkward twice. That's how bad it is. Cool. Okay, great. Okay, so without further ado, allow me to please introduce Chris. Chris is the CEO and CTO at The Molecule, a company specializing in visual effects and virtual reality in New York City and Los Angeles. He is also a VFX and VR supervisor, consultant, and software developer. Chris has worked on a variety of films and television projects, including Elementary for CBS, Doug Liman's film, The Wall, and most recently, Lincoln in the Bardo, a VR experience for the New York Times. That's also a great book, so you should read it. Anyway, without further ado, let me welcome Chris.
Great book.
The first thing I have to say, above all else, tough act to follow. So, Penrose, you guys are amazing. Google VR, you guys are amazing. So, I'm going to show my deal. Our work is primarily photographic, so we're not generating VR from OpenGL. We're actually capturing it photometrically. And I just want to step through that process because I think that a lot of people don't necessarily realize all the parts involved with VR photographic capture. So let's start. These are some of the projects we worked on. Invisible, very popular. Lincoln in the Bardo, that was on New York Times app. We did a piece for Conan O'Brien recently. We also did one for Scream Queens. I mean, we've done a bunch. Didn't have enough screen space to get it all on there. Oh, do I have the videos? How do the videos work? Say it again?
Just back out. You have to exit out to go to your videos. You just have them in a file. Unless they're in your presentation.
It's all PDF.
Okay, so do you need me to launch those for you?
Thought you had them opened.
They're right here. Which ones do you want?
Great.
I had a mouse up there for you.
Windows. So this is the trailer for Invisible. It's a pretty unique piece because it is a very fast cut VR episodic series. It's within the scope of VR. It's actually quite long, in the sense of over 30 minutes. So so if you watch VR, this is actually a pretty unique piece.
There's nothing playing.
No.
There's nothing there.
Windows doesn't play MP4?
I don't know. I haven't had any issues. It's playing your file right now.
Okay, well, we may have to skip this file. In fact, we may have to skip all the videos and just talk tech and not watch anything. So just, it is helpful for me if anyone can ask questions. That's always helpful because, oh, there we go. But we have no audio.
I gotcha. Okay. Are you able to control this? I'm gonna go get your audio.
Okay, sorry guys.
Today's top story, Dr. Richard Ashland, CEO of Ashland Agriculture, died in his home in Greenwich, Connecticut. They are an incredibly secretive family that has shied away from public scrutiny, usually behind layers of publicists and carefully managed media relationships.
I, Dr. Richard Ashland, being of sound mind, have chosen to leave my entire fortune to my granddaughter Tatiana Ashland.
Where's Tatiana?
She's on her way to New York.
I want you to do something for me.
That girl is an asset no one knows about her. We can do what we want with her. She's the key to our future.
You know, my grandfather left a message for me before he died. He said someone was going to kill him.
He was delusional.
You can clap or not clap, it's fine. There is a lot going on inside of this. We've got shots underground, we've got drone shots, we've got slow motion, fast motion, we've got visual effects. There's really a lot going on in here that is very unique to VR stuff. I think SIGGRAPH is kind of a nerd festival, so I just want to dump into nerd stuff, and let's just do that. Cool. So just some of the cameras that we used for invisible. So this presentation is going to encompass more than just invisible. It's just a general VR thing in terms of capturing photographic data. So we have nodal heads, we have parabolic lenses, we have toric lenses. I think this is just plain old interesting. So I think it's good to get the information out there and just to show everyone, because they don't necessarily, not everyone is aware of all the different production techniques. You've got these smaller camera rigs, which are 2 or 3 lenses in one body. You've got these multi-camera rigs. These are actually the best ones. They're a little bit complicated. And then you've got some of these more consumer level ones where consumer is a bad word maybe, where you've got 5 or 6 lenses in one body, and it's a little more manageable on a single desktop. We used all combinations of this for Invisible and for Conan and for Lincoln in the Bardo. I think this one is particularly interesting. You get super duper high resolution. I mean, we're talking 20K VR images coming out of this rig, but always the goal with VR is to get the smallest radius possible of any camera rig. So this is like quite a large radius, but tons of resolution. So quite interesting. This is like the exact opposite of working in CG space or rendering Google Earth, for instance, or what Penrose is doing. Like we're capturing real world data and trying to figure out how to stitch it and play it back. So kind of a different problem. I think these are some fun images for Lincoln in the Bardo. We shot almost all of it over green screen, except for the space in Greenwood Cemetery in Brooklyn. We were just nominated for an Emmy, which is awesome, so we'll see what happens. I think a really important aspect of VR production is remembering that it's not necessarily all coming from one camera, right? Like, it doesn't have to be one camera. You can shoot it in a million pieces. In the VFX culture, at least as we do it, we shoot 1 million pieces for 1 million things, and you assemble it all afterwards. So you have to do a lot of math. You have to write down all the parts, and this is the way we did this piece. If I don't know if anyone has seen it. It's been very popular, and people seem to like it. Here's a picture of Doug looking at the Intanai lenses, which I really admire the Intanai lenses coming from Japan. They really have solved 1 million problems for us. So Intanai lenses on GoPros. So these are the 220-degree version. GoPros are not gen locked, and they also auto balance for color, so that's a little bit problematic. But the fewer lenses you get, the easier it is to deal with in post. I think this is a fun image. This guy basically is invisible for the whole film, so this is the one time you might get to actually see him. We used Steadicam during Invisible, which is also a pretty unique thing. In the story world of Invisible, we would actually use the point of view of an invisible person and hide the camera operator. So in VR, it's quite difficult to have any kind of moving shot. You either have to have a robotic thing or a drone or some kind of a like a rig on the floor or something. So in this case, we basically just wrote it in the story that in our VR world, we would mirror the foreground against the background, and we would call that like kind of the invisible point of view. It's this thing that keeps coming up. You really want to have a moving camera in VR space, but it's quite difficult to do. I'm going to skip that one for now. This is a kind of a picture of a lot of the gear that we used on Invisible. This is also quite unique because when we were shooting this piece, there were only 18 jaunt cameras in existence on planet Earth, and we had 3 of them in the same city on the same production. So that was like quite a special moment, and I don't know, quite proud of this picture actually. Just to emphasize one more thing, we're doing tons of weird stuff in VR right now, and this is a picture of my friend Lewis doing underwater Shark Week 360 stuff. So, so the thing I want to emphasize is use your imagination when it comes to VR, because there is no limit. So just to get into a little tech moment here, basically whatever camera setup you use, you're going to be converting some form of fisheye information into some kind of stitching format. We use Nuke, but this is not particularly special because AutoPano VR, Hugin, PT GUI, they all kind of work the same way, where you create a camera profile that will translate some kind of weird fish-eyed thing in some kind of spherical format into a camera placement. So if I can just back up for a second here. So each one of these lenses is capturing information. We need to convert them into a lat long of some kind. So we end up with something like this. Once you have defined a lat long format, or sorry, a STMap format that gets you into lat long, you can kind of run any shot you want as long as you know what your camera rig is. So this is a lot of what like Cara VR, for instance, is doing, and Cara VR I also very much admire. This is kind of the minimal Nuke rig. It kind of builds from there. We've got, so this is the project that we did for Conan VR. You'll notice that upon an initial rig, you have to, there's a lot of stuff that needs to be painted out. You have to paint out our operator, paint out our tripod. This is what we want to end up with. It's quite difficult to get there. Sorry, this is getting a little messy here. One thing to point out is that if you're viewing things in lat long space, you need to remember always to view it in a headset. This is the actual shot when viewed in the headset. So these two are quite different. I've seen a lot of people work in VR space and just kind of forget to work in a headset. This is kind of a thing. Just please always view something in a headset. Our comp will start to get very complicated as you paint out parts of the floor. Let me just view the trailer in lat long space here.
Today's top story, Dr. Richard Ashland, CEO of Ashland Agriculture, died in his home in Greenwich, Connecticut. They are an incredibly secretive family that has shied away from public scrutiny, usually behind layers of publicists, and carefully manage media relationships.
I, Dr. Richard Ashland, being of sound mind, have chosen to leave my entire fortune to my granddaughter Tatiana Ashland.
So part of what I want to show here is that
Where's Tatiana?
this is the delivery
She's on her way to
format
New York.
that we are producing.
I want you to do something for me.
So it's a top-bottom 4K by 4K, or really 4K by 2K times 2 format at 60 frames a second.
You know, my grandfather left a
Stereoscopic.
message for me before he died. He said someone was going to kill him.
I mean, if you've worked in VR, this is nothing new. If you haven't worked in VR, this might be surprising. So I just want to step through stitching cleanup. This is probably the most number of man hours that we spend on VR work. It looks simple. It's not. You're constantly converting between spherical space and, I guess, projected space. You always have a tripod. You always have some, whether it's a sandbag or something, you've always got something to paint out, like virtually every single shot, whether it's a drone or whatever. Tools have been created to do this. Mocha VR is great. Cara VR is great. Spherical transform in Nuke also works. Using just a plain old cube map in After Effects, that also works. Usually you want to convert to something planar like this. You use Photoshop or Nuke or whatever paint tool you want to actually paint out the floor chunk. It's quite destructive to paint and then invert the spherical transformation. So rather than inverting the spherical transformation, we just do the patch and then convert the patch spherically, which gives you something like this. And then that overlays against your original shot. It's way less destructive. Depending on what camera rig you're using, you might have a 4K stitch or a 20K stitch or whatever it is. But either way, you're probably not finalizing the shots at 20K, probably at 4K or 6K. So I just want to step through some visual effects. I think that there is a little mystery here. I think that there's tons of big fancy camera rigs out there. My favorite way to do things is the simplest, like smallest number of fewest, what is the word actually? The fewest number of lenses is better. If you can use a nodal head, if you can use a parabolic lens or a toric lens, you actually end up with less problems in post, is my opinion. So for this production, we shot with A7 lenses, Sony A7 on a very small radius. We shot the scene 4 or 5 times, so that if you look at it, there is actually a combination of each frame that will allow a complete frame to exist after the fact. So once you add it all up, you end up with something like this and then something like this. So it's cheaper that way. You have less lenses. You end up doing a bunch more work in post, but it's more perfect. So we shot everything over green screen. This I think is quite interesting because we ended up shooting, we only had to have one camera on the green screen stage, which is pretty cool because you don't need 20 cameras necessarily. We needed to know a lot of data about the lenses, or the lens, because everything was shot on an 8mm lens. We measured it, we angled it, and we knew exactly how to key it and how to unwrap it so that we ended up in a perfect, basically a perfect spherical space, if you can call it that. A few more transformations, we end up adding the whole group together. We have, I don't know, we shot 15 people, I think. We ended up with about 200 in the crowd. Oh, sorry.
An unprecedented occurrence.
So this is the director's view.
He is. I don't know how to. He carries the boy's sick box. He kneels.
So I mean, it all kind of plays, but
My God.
you got to remember,
He's
there's
going
like
to pick that
40 or 50
child
layers
up.
going on here.
The very idea that someone from that other place would deign to. It's the touching that's unusual. The holding. The lingering. The kind words. God, my God. To be touched so lovingly. So fondly. As if one was still. Healthy. As if one was still. Worthy of affection and respect. It gives one hope. We are perhaps not so unlovable as we've come to believe.
Running out of time a little bit. Here's some visual effects work we did. It's just worth pointing out that I think VR has a mysticism to it. It's really not. It's just plain old rotoscoping and painting and all the regular tools that everyone uses. We sent this work to India. They did an excellent job. It was 9,000 frames times 2 eyes, so that's 18,000 frames. So it's great. We did a lot of the work in anaglyph format, simply because you can't have a whole studio of 3D monitors. Like anaglyph works just fine. We used it. It's awesome. Sorry, I'm just a little bit of a rush here. Just want to show our fight sequence because I think it's awesome. and hopefully it encourages you guys to view it online.
Check it out. I'll take southbound bridge. Got him. They're on the run.
Cool. Just want to make sure everybody gets proper credit, but thank you very much. If you have questions, let me know. I'll be here after the show.
Thank you so much for coming to our session. Up next, we have our next session that will be chaired by Mark Alent over here. And if you're interested in it, please stay and enjoy the rest of the conference.